My name is Hannah Fieldsend, and I work in the data team at Esri UK with a focus on commercial use cases.
And my name is Síne Kelly, and I work in the professional services team, helping customers within the public sector.
We're both keen advocates for imagery in GIS, so we're really excited to talk to you today about some new capture techniques and tools for managing your imagery content within the ArcGIS system. ArcGIS is already a pretty comprehensive imagery system, consisting of products that generate data layers from all different types of imagery. It consists of hundreds of tools for analysing imagery, multiple types of experiences for visualising imagery, as well as many options for sharing, hosting, and managing imagery content and its outputs. What we're also highlighting here today is the reality mapping part of the system, and that's the ability to create an accurate digital representation of the physical world using images, LiDAR, or both. You saw some of this briefly in the opening plenary this morning. Reality mapping in ArcGIS consists of a family of products, some of which are focused on high-resolution drone imagery, all the way through to medium and large-scale aerial and satellite imagery. But all of this is powered by the same underlying tech, the ArcGIS Reality engine. This engine is what transforms remotely sensed imagery into content information, such as highly accurate maps and 3D models, some of which we'll be demoing for you today. So I'll start by passing over to Síne to talk about reality capture and reality mapping, what this means for our GIS users, and demo some of the newest products available within this space. And then we'll take a look at some of the newest updates to our software as a service imagery offerings, including author rectification and creating foundational data layers using image for online. Finally, I'll demo some of these outputs, including a high-resolution 3D mesh created using Reality Engine. So over to you, Síne.
Thanks, Hannah. First of all, let's just check. We've heard today people talking about reality capture and reality mapping. But what do these actually mean, and what's the difference? Reality capture is the process of creating digital representations of objects or assets. This could be a representation of my computer mouse, an object without necessarily any geospatial reference. Reality mapping is a process of creating digital representations of assets in the real world, sites, cities, and countries, with a high spatial, spectral, and temporal accuracy. And this is what really matters to our users. But why does reality mapping matter? As you saw a bit in the plenary this morning, this allows us to generate foundational content for our digital twins. We can create content, 2D and 3D, which is highly accurate, up-to-date, and photorealistic, providing geographic context for our data, making it more engaging and approachable, particularly for our non-GIS users. Within ArcGIS, we can support a variety of platforms and sensors, perform reality mapping at very different scales, and all within a variety of deployments. It always starts with input imagery, from drones, aerial imagery, or satellites. This imagery can then be processed to create 2D and 3D content products, such as true author mosaics, digital surface models, and 3D point clouds and meshes, to name a few. All of this content can then feed our GIS and BIM systems, which help us to perform a variety of tasks and make better decisions. These end-to-end workflows are all possible with ArcGIS Reality, our suite of photogrammetry products that can harness the data collected through reality mapping to generate foundational content. ArcGIS Reality has 4 different faces, each suited to different types of imagery, size of your area, and needs of your users. So whatever your organization's requirements are for reality mapping, we've got you covered. The first 2 faces of ArcGIS Reality our drone users may already be familiar with. This is site scan and drone to map. SiteScan is our cloud-based end-to-end drone mapping solution that allows users to capture, process, and render a site in both 2D and 3D, and feed that content into your ArcGIS. If you need to work in an offline environment, you can use Drone to Map, a desktop application which allows you to perform rapid processing without access to the internet. Now, these drone products are great for small-scale mapping of your sites. But what about large area mapping of cities and beyond? And what if you want to use aerial or satellite imagery? This is where our newer ArcGIS Reality products come in. ArcGIS Reality Studio and ArcGIS Reality for ArcGIS Pro. ArcGIS Reality Studio is a desktop application that provides an end-to-end solution for aerial mapping at city and countrywide scales. Drone users can also use Studio for their large area content production. It's a highly focused, standalone application, so you can use it without any other experience of the ArcGIS system. This is great for some users, such as aerial survey companies and content providers. The workflow is highly intuitive for such a technical piece of software, making large-scale image production much more efficient and producing results with survey-grade accuracy. ArcGIS Reality for ArcGIS Pro is an extension which brings 3D reality mapping directly within ArcGIS Pro. So for our users who are already familiar with this piece of software, it brings your end-to-end reality mapping solutions in-house for any scale, site, city, and country. It provides more flexibility to work with different types of sensors and using different collection parameters. Again, the workflow is highly intuitive, so you can create a variety of high-quality outputs with just a few simple steps. Let's take a look at one of these now. I want to show you just how easy it is to create a 3D mesh using some drone data taken from a survey of the Royal Engineers Museum in Kent. This is a military engineering museum and library which tells the story of the Royal Engineer Corps. We start by opening an ArcGIS Pro project in the usual way, and then we can create our reality mapping workspace. We can give our workspace a name and define the sensor type that we're using. In this case, it's drone. I can then add my drone image collection from a locally saved folder on my computer. Once all of the images have been loaded in, ArcGIS Reality will automatically populate some of the parameters for us, such as the camera model and the spatial reference. I can leave the rest of the settings as default and press Finish. Creating the workspace will take just a minute or so. And once this is done, I can use my new reality mapping view to run a block adjustment, which will improve the geometric accuracy of my data. Running the block adjustment will tie and orient my images together using tie points. Tie points are common objects or locations in the overlap area of my adjacent images. Running a block adjustment does depend on the size of your data, but in this case, it took me roughly 90 minutes. Then once this is done, like with SiteScan and Drone to Map, we have the option of using ground control points. Ground control points are known coordinates on the ground that can be used to georeference our images, increasing the absolute accuracy of the adjusted imagery. We can manually add or compute ground control points using a referenced image layer, or you can import physical control points that have been placed by a survey team. In this example, I've just used the default imagery base map and manually added my own ground control points, which you can see here shown by the green markers on the map. I can also use the Ground Control Point Manager, which will show the ground control points listed here on the right. Now these are added, I can add some additional tie points. Using the image viewer here and the list below, I can see all of the images that overlap with each of my ground control points. ArcGIS Reality will automatically calculate many of these additional tie points for me, but I can update these or add more where necessary. Then once I'm happy with all of my points, I can rerun the block adjustment, and then we are ready to create our final product. ArcGIS Reality for ArcGIS Pro allows you to create true orthomosaics, digital surface models, or DSMs, point clouds, DSM meshes, and 3D meshes. We can even create multiple products at once, but in this example, let's just focus on our 3D mesh. Using the advanced settings here, I can specify the quality of my output, from low to ultra. Let's go with ultra to create the highest quality product. Again, I can leave the rest of these settings as default and press finish. Fast forward a couple of hours or so, and I have a 3D mesh which I can add to a new local scene. Now, this may take a moment or two to load, but once it does, you'll be able to see the high quality detail in the output product. And of course, as you would expect, we can upload all of this content to ArcGIS Online. I'm going to pass back over to Hannah now, who's going to show us some of the exciting new things that we can do with our reality mapping content online.
Thank you, Síne. Sorry to take everyone away from the lovely model there. So following on from that presentation, you can see that we're building up a truly complete picture of our imagery workflow. So starting with sensors and reality mapping to create digital representations of physical assets, we can then start to derive insights from our imagery. Using the image management and analysis capabilities available within the system. Using ArcGIS Image for ArcGIS Online, we can host and manage imagery in the cloud. Organizations are already using these outputs to create accurate site models, extract observations for monitoring and intelligence, and identifying spatial patterns such as habitat loss and urban growth. Beyond managing your imagery in the cloud, other functionality under ArcGIS Image provides photogrammetry, AI, and raster analytics tools that underpin a variety of different use cases. Now let's take a look at processing some imagery in our desktop software. So in ArcGIS Pro, we can process razor-sharp aerial photos with perfect location. Here I have a DSM orthophoto, or true ortho, over Romsey in Hampshire. This imagery was provided by the Ordnance Survey and has a 6-centimetre ground sampling distance, collected using the airborne sensor system, the UltraCam Eagle Mark II. This imagery has been author-rectified using the ArcGIS Reality for Pro extension, so we've now got a true top-down view of the town. When I swipe across here, you can see the world imagery base map to the left, and in what we call this traditional orthophoto, there is perspective, which you can mainly identify from the buildings, such as the Romsey Abbey here. The buildings lean over or cast great shadows, so an orthophoto never lies perfectly on top of or underneath other map layers. With the true ortho, the correction of the tilt ensures high accuracy aerial photos, which are extremely suitable for many applications and processes, such as base map creation, object recognition, and looking at change over time, or as inputs for ArcGIS Image for ArcGIS Online. So now I'll show you how we can use this true ortho to create some foundational layers using Image for Online. At the centre for our vision for imagery is image services. Image services provide a modern way to empower users to work with massive amounts of imagery from all different sources. Because image services let everyone access and work from the same imagery, they help you eliminate redundant data image silos and democratize the use of imagery across an organization. Since my talk at last year's conference, ArcGIS Image for ArcGIS Online has only scaled up in terms of making imagery accessible within a secure, scalable environment. We can create tiled or dynamic image services even more quickly within our online organizations, and now there's a few more raster-type properties that we can use. So my input imagery is processed 8-bit, and the compression will be working with JPEG images. There's some further processing options. I can type in my spatial reference system, which is British National Grid, and there's a couple more metadata options you can add in, such as acquisition date, measurements in units, and custom band mapping. So you drag and drop those images from your local machine. So I've got some TIFFs here generated from that UltraCam Eagle sensor. Give the layer a name, and you've just created your own hosted imagery layer. You can now also export your hosted imagery as tile packages to support offline workflows. And there's the handy credit calculator keeping us in check there. So with Image Online, you don't have to worry about infrastructure management. Instead, you can work with imagery as fast performance services in a secure and scalable software as a service. Image Online has also been designed to use the GeoAI deep learning models to automatically extract features from imagery. In the new Map Viewers Analysis tab, we can use the deep learning tools to detect objects. We can input our newly created hosted imagery layer and select from one of the growing list of deep learning models available within the Living Atlas. So these can help you detect and classify objects like buildings, roads, swimming pools. There's even an Arctic seal and elephant model here, if that's what you're after. But I'm just going to use the car detection model. So we select the model for the features that I want to extract, and behind the scenes, Image Online is spinning up multiple GPU processors to handle this additional processing task. It took around 2 hours for the model to extract all of the cars in this square kilometre area, and a further 2 for the model to extract all of the roads, turning them into vector layers that I can then analyse and share across my organisation. This is a really powerful way that Image Online can help modernise your imagery production workflows without needing to invest in your own infrastructure. In this web scene, that initial true ortho that we started with has been processed into a 3D mesh using the latest Reality engine. The mesh is an intuitive representation of the objects captured by the imagery in a 1-to-1 scale, with the geometry and texture information from the images carried through into the mesh. The 3D nature preserves details on the building facades, as well as features under bridges, suspended structures, and trees. The accuracy and photo-consistent textures help make the surface model realistic when viewed from every angle, and by optimizing its structure into small files, the output mesh provides really good performance while loading or streaming these large data sets. Draping over that foundational data we extracted from the True Ortho Imagery service allows further interaction with the model on desktop applications as well as web-based 3D viewers. Here we've got the OpenStreetMap Amenities for Europe layer hosted in the Living Atlas and visualized in our scene for a complete immersive experience. In this afternoon's session, you've seen new options for reality capture and mapping with high geospatial accuracy and photorealistic content. We've shown true orthos and 3D meshes, and we've talked about how we can process, optimize, and analyze small and large-scale outputs using ArcGIS Imagery. And above all, I hope we've inspired you to check out the underlying engine that powers it all, the exciting new Reality engine. Thank you for listening.